Hello guys, welcome to SipCode, and today we are looking at another cup of code. We are talking all things Quartz microservice. We'll be looking at Spring automation and how we can create cron jobs, schedule the jobs whatever time that we want or whatever time that we feel like, and basically watch those jobs execute in real time. And we basically have some tips and tricks on the implementation on your specific workplace or workspace, and basically in your microservices architecture you can start automating some of the processes that you have, and instead of running them manually or triggering them manually, you can basically rely on some automation capabilities within the Spring framework. So let's have a look at that and basically continue with the code that we have today. So yeah, I'm gonna start with the Spring. Let me start with the demo of the microservice, and then I'll showcase the rest of the code as we go. So yeah, that's it. Stay tuned. Let's see what we got. So the microservice, or the Quartz microservice, is what we have the artifact as, and we can basically get that in our Git repository. If you want the source code, just go to our Git repository and pull the source code, or just click on the link in the description below, and you can basically access that and basically use it on your site. Weird. I'm saying basically a lot. So yeah, that's about it. Let's go to the demo so that you can see what we are basically aiming for. Again, basically what? I think I need to start a basically count on my side. But besides that, let's have a look at the demo of the project. Let me start it up quickly and we can see how it looks like. We're gonna run this in our Postman. So let's go to Postman, and I have the Quartz microservice over here, and I have a number of endpoints. So the first one is create job, the second one is get job list, and then the third one is start the job, stop the job, pause the job, and resume any job that is paused or stopped. So we're gonna use the Quartz Scheduler to basically trigger this start and stop, and basically the resumption of the particular job that we decide to stop. And there is a front end Angular project that I already demoed that also uses cron. So this microservice is essentially catering for that particular front end, and I will do the integration to the Angular project in the next tutorial. So please do stay tuned for the full integration of Angular into Spring microservices architecture, so that you can see how we tie together the back end to the front end, and we will work with that project. So if you look at Cron Express in our Git repository, that's the repository for the front end, and this is where I will basically plug this particular back end. So let's start with creating a job. Let's just see if the service is up. Yep, and the application is started successfully. So let's just create one cron job. Let's just register this particular one, or let me just rename this into, let's call it report microservice processor, something like that. And basically I can take this, just copy this, so I'll just send this job creation, and you can see that we've created a job right now, and this job is now available for us to run. This runs every 30 seconds. We have the cron name, the expression, the class GMD, which is the Java name, and then we have the description, which is basically just telling us what the job is all about. But this is just a test, so you can have the same payload on your side, and then I will explain more in detail the class GMD as to what it essentially entails. So now that we've created the job, we go back to our console, and you will see in the console we have our application, and the bash job was created successfully. This is the log that we have, and then that the job now is available, and it's basically going to execute just like it's doing now. So you'll see welcome to SpringBoot external page processor, execute your external business logic here, and it's already executed twice since we've created the job. So we created it here, and it basically captured that the job was created successfully, and now it keeps on executing. Every 30 seconds it's going to execute this piece of code, and I'll show you where the processor sits, and you will basically have an idea of how you can create your own automated jobs and be able to create to register new jobs dynamically via the service, and be able to control how the jobs start, stop, pause, resume, and things like that. So let's register another different service. Maybe let's call this one library microservice processor. And I do have another processor available in the project. So let me just call this internal processor, and you will see how this will execute quickly. So let me just run this particular registration, and that service has been registered. Library microservice has been registered. So now I'll go to the get job list, and I'll send that, and now I can see the jobs that are available within my Quartz scheduler. And when I go back, now we expect two jobs to be executing at the same time, and you will see that the latest logs, I have welcome to zip code external, and I have welcome to zip code internal. And that's because the first job is the external processor, and the second job is internal processor. So these jobs will execute every 30 seconds, just like we added our Cron expression over here, and we will keep on getting these two processors running every 30 seconds. So that is about it with the project, and I'll basically now run you through the code. And this particular piece of code is available again in our Git repository. Please do pull that code base, play around with it, see what you can do, see how what you can learn and implement on your space, and basically use what you can. And if you have any concerns or questions, please pop those in the comments, and then we'll address those accordingly. But for now, let's proceed. And then if I want to start a particular job or stop a particular job, let me go to the stop job, because there is a processor that is already running for both of these jobs, so they keep on populating the logs. What we're going to do now is just stop the report microservice processor. So this one, I want to stop it, and I want to send this particular request. I get a 200 OK. Now that I've stopped that, and if we come back here, you will see that after 30 seconds, we will only get one processor that will print out. So let's see. Let's just wait for it. This is 9. Okay, this one executed last, and then let's wait for the next log to come through. Then you will see that only one will come through. The external will not come through because we've stopped the external processor from executing. So basically we've interrupted it so that it doesn't continue to execute. All right, now as you can see, we have internal processor that came through, and the last one also was an internal processor that came through. If you look over here, so the external processor is no longer executing because we've stopped the job, and we can basically come back and start the job over here with this start job endpoint. Let's just go and specify the processor name, and we send that. And if you come back, you will see that the job started with external that is printed now. So welcome to SpringBoot external page processor, and it's executed because we've started the job with this endpoint. And within the next 30 seconds, you will see two logs that are going to come in, and it's going to be the external and the internal one. So both of them will continue running as per usual because we started the external job as well. So now, as you can see, we are seeing external and we are seeing internal as per usual. So let's go back into the endpoints. We can also pause the job. Let's just wait for it to come back. Maybe let me do this. Let me just clear this and then wait for a new log to come through. So as you can see that both of these are actually running now, and we can then test the pause and resume. So okay, only one came through. So let's go back and resume. Let's just resume the job over here. That's the one we wanted to pause. Now we want to resume that one. So let's just wait for it to come through, and let's see how it looks like. We'll give it about a couple of seconds, and the scheduler is only kicking off this one. That's the one we want. We want to kick off. The microservice processor. Now let's see. Okay, now it picked up that the external needs to start, but it needs to basically proceed as well. So, but then that's fine. Let's just go through the code, and then we'll basically address this particular issue here, which is a good thing also that we know that there is a concern that we need to address quickly. So let's go back into the code. So first things first, we will go through initializer. That's where we start all the time. The project name is a Maven-based project. No, not the project name. The project is a Maven-based project. And then we have the language is Java. The Spring Boot version 3.4.1. Always take the latest stable version that's available for long-term support. And that's what we always recommend. The project metadata, we have the group, which is com.zip code. The artifact is Quartz Microservice. And then the description is just a demo for our Spring Boot feature, which in this case is Quartz Scheduler. That's what we want to showcase. Package name is the group.artifact name. And then the packaging is jar. The Java version that we're using is 17. Another dependency that needs to be always long-term support. We aim for that. So take the latest stable version. Use that across your projects. And on the dependency side, we always have DevTools for live reload when we make code changes. Then we have Lombok for ease of boilerplate code for access modifiers, POJOs, and annotations that allow us to easily log or import classes that we can reuse with boilerplate code. And then Spring Web, because we are creating a microservice, so we're going to have RESTful web services with our controllers, as you saw within our Postman over here, and that's the aim. On Spring Web, we have Quartz Scheduler, which takes care of our scheduling and automated jobs for automated execution of certain processes, and that's the aim that we are going for. And then we have liquibase to maintain and manage our database changes. So basically, it's a version control for our database to make sure that we always have the latest changes, maybe rolling out as part of a code change, and basically easy maintenance and management of our database structure. And then the H2 database, in-memory database, this is basically for us to scaffold the database on the fly with as part of the package of the application itself. Because this is a demo, that's why we're using H2. It's easy to run and execute. Its life cycle is basically part of the application itself. So we don't want to do some heavy lifting with maybe a different RDBMS or a different RDB, to put it that way. So in this case, we just have the H2 memory DB that makes life easy for us to package this as part of the application. So if you pull the code and run it, it will still run as if you are connected to a real-world database. So you can just pull the code, run it, it will basically create everything, and then you just call the different endpoints and it will run as per usual. Then Spring Data JPA, obviously we are interacting with the database, so we do need to have our data JPA for us to communicate and transact with the database for whatever reason that we want. and in this case to create our cron jobs or Quartz jobs, and basically start them, stop them, and remove jobs that we want. And that's about it for this particular project setup. Let's jump into the actual project. Now we're going to go to our IDE, Spring Tool Suite, that's what we use. If you are IntelliJ guy, that's still fine, it still works perfect, there's no issue over there. So let's do what we do best in our code base. So let's start on the application properties. So application properties, one annotation that is very key is at enable scheduling. That's what you want, so that Spring can register as a scheduling service. So this enables us to basically run Quartz jobs and basically scaffold Quartz data tables within our database. And we do have properties that we need to set. So let's jump over there to see those properties as according to the Quartz setup. So the first things first, we have the application properties, which is the application name Quartz microservice, the server port 8080, whatever port that is available to you, or whichever one you prefer, you can use that. And then we have database or data source config, which is the database that we're talking about. S2 memory database, the database name is Quartz Cron DB. And then we put the driver class, the username, the password. So these are default configurations for the data source. So the username is SA and the password is password. The S2 dialects, that's the database platform. Then we basically are console enabled through console path. If you want to see how the database looks like, you just go to S2 console and then you will see how your database looks like. And then we have Hibernate DDL auto update. So this will update the database as and when the changes that need to be pushed to the database based on the Hibernate DLL auto config that you want. You can set up different levels of this DLL auto config. You have create, drop, none, update, validate. So based on your preference, you can choose one and use that instead. So we'll stick with the update for now, which should suffice for what we want to do or achieve our objective for the database config. The next one is the Swagger OpenAI config, which we're using Spring Doc Swagger UI.path. And this particular dependency, as you can see, is not yet available in the initializer. So let's go to, if I say add, let me just say Swagger. This is not available in the recording of this. So we will basically be needing that Swagger documentation so that it's easy for users or consumers of our microservice to actually see what endpoints we have and basically scaffold requests on the fly without having to write any of these manual collections that you'll have to do here in Postman. So they can basically have the documentation as part of the application and go to, let's say, localhost. Let's just do 8080. The endpoint that we used is that one. So as you can see, now it's not available for us. So let's go back to the application and application that. Let's see if that is available to us. Enable, let's see, it should be Swagger or OpenAI, which is not available. I think one thing that I need to check and confirm is this particular dependency over here, which is OpenAI Web UI. Where is that guy? Where is that guy? Did I add that? It doesn't look like I added that dependency here. Yeah, I don't have that dependency here, which is cool. What I can do is Spring, let's say, open API Swagger dependency. Let's go there. Snap. What's going on with my connection? All right, cool. So my connection has some issues, but that's fine. Um, so what I'm going to do is I'm going to add that particular dependency here after this one, and then I'll push the code and make it available. So by the time of the release, you'll basically have that dependency for the web UI, and then you'll just go to localhost 8080 swagger UI.html, and you will get the swagger doc in this particular URL actually. So this is fine. There's no issues here. And now that we are done, we wouldn't need to configure anything else. We just need to add that dependency for the Swagger, and then everything should work as per usual. That's fine. The next property that we have is Quartz config. So Quartz config, we start up Quartz, enable Quartz, the cluster, table prefix, what the tables need to look like, their prefix, and then we have the driver delegate, the scheduler name, the job store type, which is JDBC, and then the jobs to complete, wait for jobs to complete, and shut down. Want to make sure that all our processes, if there's a running process, wait for it to complete before you then shut down the application. If you need to bounce the application based on whatever requirements. Then we have liquibase configurations here. Liquibase configurations is for database versioning and maintenance. You can basically go through these as well, which are pretty much straightforward. And yeah, that's about it in the application properties that we have. And let's go and see what we have. Let's see. Let me just highlight on the liquibase changes. You will see that in the main resources we have a DB folder, and then we have a changelog folder, and the files that basically handle the changes in the DB. You have the changelog.xml, which houses or hosts the queries that we want, or the changes that we want to execute within the database whenever the application is spin up. So if we're creating new tables, we will have all our change sets sitting here, and we will be executed based on which change set has been introduced and is not available in the database. Then that particular change set will be executed. Whatever query that you want to do, create a table, update a table, add a column, insert, update, delete, whatever query you have, you can basically add it into a change set, and it will be executed on application startup, and that will basically version all your database and make sure that it's aligned across all different environments. And that's about it. So now that we have hashed out the liquibase setup and the config files for liquibase, and the properties have been highlighted as well, let's continue with the development, right? And now we're going to start on the scheduler controller. So scheduler controller is our REST API that we will be using to run all our job registration, starting a job, stopping a job, and pausing, resuming a job. So that's this is our REST controller, and as you can see, we have our Self4J for our logging if there are issues or whatever our log that we want to print out to the console. And then we have our REST controller annotation, and then our request mapping, which is schedule. And if you can, if you go back to our Postman, you will see that the endpoint is base URL, which is localhost 8080, and then schedule. And then in that particular schedule controller, we then have these endpoints that we will be executing just now. So we have our request mapping and schedule, and then within that particular controller, we have dependency injection of the Quartz Job service. Quartz Job service is the one that houses the business logic in terms of creating jobs, starting, resuming, stopping, and that business logic sits in our service, which is our business logic layer. And after that, we then have our different endpoints that actually execute the different requests that we have. And let's go through all of these. let's see, we have our post mapping for registration. This is when we register a new Quartz or a new cron job, or a new cron schedule, and that's the register endpoint that creates the job. We just take a request body of Quartz job. So let's look at how these Quartz job looks like. The Quartz job implements serializable, so we're serializing the payload that we'll be receiving. We have all these Lombok annotations at data, at get, at setter, all args, no args, constructor, the builder, at entity, because this is a database entity. So we want Spring to be aware that we are dealing with a database object. And then the table name is Quartz job, and we have our JSON ignore properties to ignore unknown properties. And then we have our fields over here, which is the ID, auto-generated ID, and then we have the name, the expression, the class GND, and then we also have the description of the particular job that we're trying to create. And that's it for our entity POJO. Let's now move back to our controller. So the request body is the payload. Once we have the payload, we just log as to the job created successfully, and we essentially just return the response of the save. So if you go to Quartz job service, the save with the payload, what we do here, we have a try catch. So if there's any failures here, it's just going to throw an exception, and we basically handle that exception according to the failure that we get. So the first things first that we do is get our scheduler, the application scheduler, from our scheduler factory bin. I'll go through the business logic or the job service in a few, but I just want to show you the save. It gets our scheduler that is available for the application context, and then we get the job details based on the payload that we just received, and then we schedule the job and add it accordingly and run that particular job over there. So what we do is job details, basically get the job details, and we basically add that particular job detail into the schedule, and then we schedule the job with the job trigger, and then we'll go through the job trigger in a few and the job that we have. And then this schedule will then execute as you can see when we create a job here. Let's just let's create one again, because we already restarted the application. So we created one now, and then let's go back here. You will see that the job is created, and in about 30 seconds the job will execute, and we'll see some new log. So let's just clear this quickly before it throws the log. Right, so now the log is coming through, so which means 30 seconds is hit and the job is running automatically without kicking off anything. So that is what we are doing. And then let's go back to our controller, and once the job is saved successfully, we then return that into we return that back as the response to the user or the particular request that was sent through to the service. Now that we saw how the request gets created, the next thing is when you update a job, we do the same thing. We take the ID for that particular job and the request body, and we go and save that particular job in the save method over here. And this particular method, we also update the scheduler to say, please update this job if it exists, and that's why we have the true here, so that it's able to update that particular job and basically change the schedule, change the details, whatever we want to change for that particular job. It will basically handle that schedule accordingly. And once that is done, we then go back to the controller. The next endpoint is pretty much straightforward. It's a get endpoint, and that's the job list. What it does, it goes to the database to retrieve all jobs. So if I click here, you'll see that it uses the Quartz job repository to find all. We don't filter anything on this particular endpoint. This is a demo, so finding all is not really a heavy lifting in per se, because we just creating like one or two jobs for demonstration purposes, so there's nothing heavy that we'll be doing besides that. So find all returns the list of the jobs that we've created, and then we have another post, or the rest of the endpoints are a post, which is the start, and we have the start with the parameter name, and this path variable is the service, or it's the job name that we want to start, or the one that is basically we are aiming for to basically trigger a start on it. And once we get that name, we go to our business logic and say start trigger, and then it goes to start that particular trigger from our schedule. So if you go to the start trigger, you will see we get the scheduler from the application context, and then we say trigger this job with this job key. In actual fact, this trigger should not be using the job key, and that's why we had the issue earlier to actually trigger this job. So let me do this. What we want to do is trigger this. Let me see. Scheduler dot trigger job with job key. Nope. Nope. Pause trigger, reset, resume. Nope. Nope. Trigger job with the job key and job map. Yeah, this should suffice. Okay, let's do that. Let me actually do this. So for us to fix this, I want to say get trigger, right? I'm gonna say new trigger, and I'm gonna say name of that particular trigger, and then once the trigger is available, let me just do trigger. Let's just call it trigger, and we'll just do the scheduler dot trigger. So once we have the trigger, what we want to do is trigger trigger dot I don't want to compare this trigger final time, get key, get next fire time, get previous, get start time. I don't want to do this. May fire again, notify. So here I'm just showing you what is available for the trigger. So we can say may fire again, and we are, let me see, may fire again is a boolean used by the scheduler to determine whether or not it is possible for the trigger to fire again. That is not what we want. We actually want to trigger this particular job to start. Good trigger builder. Nope. So this is not available here, which is why it should be available at this level here. Resume trigger. Let me just do that and then remove this guy here, right? Cool stuff. Let's save this. So here let's use the resume trigger with the trigger key with the name of the trigger key that we have. So we'll just use that to resume it. Let's go back to our controller. So this particular endpoint will then start the trigger based on if it stopped or not, and then we'll basically start the trigger based on that particular submission. And then the next thing is pausing the job. So pausing the job is we get the same parameter, which is the path variable, which is the job name. Then that particular job name, we just go and pause the trigger, and we go to the pause trigger. We get the scheduler that we are running in the application context, and then we go and stop that particular trigger or pause that particular trigger rather over there. And then the next one is stop, which is the same premise, stopping the trigger, and the resumption or resuming the trigger, we do the same thing. So now that we have seen what our controller does in a nutshell, let's jump into the Quartz Job service dependency injection. Let's see what that logic looks like. So here in the job service, we have our self4j annotation for our logging from Lombok, and then we have our add service so that it registers as a service bean in our Spring context. And then we have our dependency injection of iQuartz job repository, which is the database repository that we'll be using to transact with the DB based on updating a particular job or saving a new job and things like that, or creating a new one. And then the next dependency injection that we have is auto-wired scheduler factory bean, which is the factory bean that handles our schedule, and we will be using that to get the current scheduler that we have and use that to start a particular job or stop or resume and things like that. So we'll handle transactions that are pertaining to the schedule itself. So then the first one is the one that we went through, which is the save the job, which is creating a new job or updating an existing one using the scheduler that we have. We then go get the job details. So if you go to the job details, you'll see that it's in a nutshell a mapper. So we have the Quartz job that we have from our POJO with the request payload, and then what we do in here, we do a try catch. In that, what we have is a Quartz processor class type that we want to return back. So when I find that class by the name that we submitted in the class Jindy. So the reason why we need the processor is to tell Quartz that for this particular job, go execute this processor that has the business logic that follows this particular job. So in this case, we have a class Quartz processor, and that particular class processor, we want to load a class 4 name, which is the job.getClassGindy. And if you get the Jindy name of the particular class, you will see that it's the com.zipcode Quartz microservice Quartz internal processor. So which means in the application, we should have an internal processor class that already exists, and then when the job is registered, it will go and find this particular class by the name and load it into that particular trigger or that particular job for it to run automatically. So now let's see this, and this is where everything gets tricky now. So let's go to Quartz processor. Quartz processor is an abstract class and it implements job, and you need this abstract class because you want your jobs to be registered with the abstract class, and Spring will then say load the classes that that actually extend this particular abstract class, and because this is the parent class, we will then be able to plug in any child or subclass that is available to us via the inheritance or reflection mechanism. So if I go to my Quartz package, you will see there's an external processor and there's also an internal processor, and the Quartz processor is here, which is the abstract class that implements a job, and it basically overrides the execute method of the job interface. So if you go to job, you see that job is an interface, and we need to basically override that particular class and put some logic over there. So if you go to the internal processor, you will see that internal processor extends Quartz processor, which means it's going to inherit all the properties of the Quartz processor, and on hindsight, it's basically a subset of the Quartz processor. And all your processors, you would want them to be subclasses to or you want them to extend the Quartz processor so that it's able to dynamically load the correct processor for the particular job that you're running. So in our case here, the library microservice processor, this guy over here, is loading the internal processor, which is the processor that is going to run for this specific job. And this particular code base, let me just do this, and I will change this log. I will just say this is internal processor, batch processor, something like that. And then I'll also do execute internal business logic. Let me just do this. Execute internal processor over here, and then I'll save this guy. And now that that guy is saved, when the application bounces, because we're using S2 database, it's going to clear the DB and create a new one. So that's fine. And then now, if I go back to our Postman and I re-register this particular service, you'll see that now the service has been registered. And when I go back to um, our IDE, you will see that the job will run and it has the new changes: internal processor, batch processor, execute internal processor, business logic here. So this is what we have for the internal processor, and the internal processor, remember, is a subclass of Quartz processor. And if we go to the external one, we can do the same thing over here and say external, let's do external processor, and we go to the other log, and then we'll say execute external processor over here as well, business logic here. Then we'll save this class, and you will see that the external processor also extends the Quartz processor, which implements the job interface. And when you're creating a job, the job details, or creating your trigger for the job, let's go there so that you will see the Quartz service. So you see here in the job details, what we do is we get the class for name, then we pass in the subclass of Quartz processor. So because of the abstraction, we're able to plug in the subclass, and it will dynamically load the correct one that we want. And once that is available, we then pass the class that we have into the job builder that we have over here. And what we do is the job builder, we create a new job of type. The type of the job is the class that we have over here, which is internal processor or external processor, or in your case, whatever processor that you want to execute that is a subclass of your Quartz processor will be the type of job that you want to have over here. And then you want to store the durability is true. You want to store and persist the job. Yes, we want to do that. And we basically pass in the ID, which is the name of the job, and the description of the job, whatever description you want to give the particular job, and you build it and you return this job details. So now it knows, because we are loading the class dynamically with the class GND, which is the full name of the particular class or the processor that we want to run, we will then basically feed back these job details into our trigger and our scheduler. So these details are going to be sent back to this guy over here. Let me just show you. So these job details we're gonna get here, and then we're gonna add those we'll add the job with the job details over here, and we'll say this durability true. Let me just updatable true. So we can basically set this boolean replace to true because we want to be able to update the details of the job. And then the next thing is schedule the job. So when you schedule the job, we actually pass the trigger for that particular job. So now the trigger is the one that holds when the job should execute, the start time, the end time, or the cron expression that will tell it how often or how frequent the job should trigger. So that's what we do. And then in the trigger, you'll see we pass the job details and the job itself. So in these details, let's go to the job trigger, and you will see these job details is what we just created now, and the Quartz job is the payload that we basically received. And then in the trigger builder, we create a new trigger for the job with the details that we have. And then we say start now. So that's why when we create a new job this side, let's recreate this one. And you will see when we come back here, the job will trigger now because we have the start now as true. And this basically will trigger the job instantly or immediately after registration. And then we have the identity, which is the job name or the trigger name. And then we have the description, and then we want to schedule it. So with schedule, to say we want to schedule it, and we use a cron schedule from the cron schedule builder, we use the cron schedule and we pass the cron expression. The expression is coming from what we have here in our payload. So if we change this cron to like on a daily basis, or on a monthly basis, on a weekly basis, on a yearly basis, whatever cron expression we have is going to pick up that expression and schedule the job based on that. And because we're able to update this on the fly, we'll be able to edit the details of that particular job. And then when the application bounces, it will be able to pick up that the schedule for this particular job is has been updated, and then it will run according to the new schedule. So that's what we're doing here. We tell it the frequency of when the job should automatically kick off via the cron expression, and it will basically trigger the job or the schedule according to that. So now that we have the job trigger available, we then schedule the job over here. And that's the final step of scheduling the jobs. And this allows us the flexibility to create jobs on the fly, and they can run, we can start them, stop them, and do whatever we want to do with them. So this is the Quartz save, and these are the inner details and inner workings of how you can basically dynamically get a job from a microservice to dynamically create it. The thing that you really need to have as a base of every job that you create is the processor that you want. So if the processor is available, then the job can be registered dynamically via your API. So the only code change is introducing the processor, giving it the business logic that you want. So let's say here we want let's maybe call it a cron microservice processor. Then we will say this processor, we want this job to execute on the external processor, and we send this particular job. And when we go back, you will see that now the external processor will execute with the code or with the logs that we sent to it. So let's just wait for it, and you will see that the job will come through just now. Let's wait for it. Just give it some time. Right. So now you can see we have the internal processor that ran through, and we also have the external processor that executed accordingly. So both jobs are now executing, and we created this dynamically. We didn't write any code to configure or to execute these jobs on application startup, but we're able to load this dynamically. And because we have the flexibility of stopping them, and we can basically just take the job name over here and go to the stop the job, or let's just pause the job instead. Let's go to pause this guy over here, pause this job, and we get a 200. Okay, that looks good. So now that the job is paused, let me clear this guy, clear the logs, and wait for the job to come back. So now that I've paused the one job, we're only expecting one to come back within 30 seconds. And as you can see, we have our internal processor running through, but the external processor is not running. So let's just clear this again. And then now what we want to do is want to resume the job. So let's go to resume job, resume this job. Let's just put the job name, Cron microservice. Let's send that, resume that job, and we'll see that there's already an old one that executed. So let's clear this and wait for the job to come back. So now we're expecting two jobs to come back because we've resumed the one job that we had. So let's wait for it, like 30 seconds, it should be back. And that should basically complete our testing of pausing the job, starting the job, stopping the job and starting the job, and things like that. So let's see if that comes back. Right, so now we have how many jobs running? We have two, which is external executor is running and internal executor is running. So we have both the jobs running, which is a good thing for us. We can basically proceed with our business logic explanation. So The next thing that happens then after the save and the job has been scheduled is the retrieve, which I've briefly explained. We go to the DB, retrieve or find all the jobs, which is in this get jobs list. If you go inside this guy, you will see that we have two services that we created, one internal, one external, which works the way that we expect. And then our job trigger, we went into details over there. The job detail we've already explained as well. The start trigger that we've already demoed and explained. We get the scheduler for the application context, and then we resume the job, or we resume the trigger accordingly. And then the pause trigger, we then pause the job as much as we want, like we did now, pause the job and it didn't fire. And then we have the resume trigger, which we then resume the job and it basically continued to run as per usual. Then we can stop the job and we basically unschedule that particular job, which is, now that I've realized that in the stop trigger, I actually unscheduled the job using the trigger name. And because I did that, in the start job, I should basically schedule the job. And that's what I need to do. So schedule the job. And when I schedule the job, what I need to do is, let me just show you. This is the actual fix that we needed. So scheduling the job means I need to get these details over here. I need to get these details over here. So I'm going to take this code, I'm going to come back here, and I'm going to put this guy over here, right? Then this job is not available at this point. So what I need to do is go to the DB and find these details. So because I have the job name, now I need to say Quartz job, which is equals to Quartz repository dot find. I need to say find by name. Let me go to my repository quickly. Let's go there, go to the repository. I'm going to create one here. I'm going to say Quartz job, and I'm going to say find by name. Yep, that's what we want, find by name. I don't want a list, I just want one object returned. That should suffice for what we're trying to achieve. So we're going to find by name over here, which with the name which we already have, and now we have the job. So let's see what is it complaining about. Okay, we need to have this in a try catch. We can do that happily, no problems. Let's just do try and catch. Let's just do. Then we're going to log the exception here. We just say e.gets message. That's fine. So now let's just catch exception e. Right, and then that should suffice. So we're gonna get the job. Let's just put this in the try catch block. So we're gonna go to the DB, get the job details, and then we're gonna use those job details to schedule the job over here. And because we already told it that the job is replaceable, so the scheduler will just replace with the with the job details that we have from the DB, and it should basically continue running as per usual. So that is the fix for it. So now we can stop the job, which will unschedule the job, and then we can add it back into the schedule via this particular fix. So this will then help you to transact, meaning create the job, stop it via this particular stop trigger method, which will unschedule the job, and then we'll come back and schedule the job with the start trigger over here. So let's put this to the test and see. But we've already bounced the application, which means we will have to create the job first. So let's if you go to the job list and run this again, you'll see it's empty because we've bounced the application and it cleared the database. So we can just come to our create job and we create this particular job, which is the Cron Microservice processor, and then oh snap, what am I doing? Okay, now I want the job name. I'll take this job name, which runs the external processor. So if you go to the logs, we'll see that the external processor is running like that. And then let's do the library microservice, and we'll run this in the internal processor. Is the library microservice, and then we'll submit this guy, and it'll basically run the 2 jobs going forward. So let's clear the logs, and then we'll just wait for the job executing to run. And once that is run, we will stop the other job. So if you go to the job list and run this, we want to stop the Cron microservice processor, which is the external processor. We want to stop that one. So we'll go to stop the job, and we'll just put the Cron here. Let's put this guy here, and then let's see the logs. And in the logs, you see we have external processor and we have internal processor. So both the jobs are running, and if about now, it should kick off again another run for the 2 jobs, and then we will stop the 1 job and see what it looks like. So let's just give it 30 seconds, and it should come through with 2 jobs executed. Let's see. Should be any second now. Right. So the 2 jobs came through. So we have the 2 jobs executed. Internal, you can see internal, and you can see external. So now we're gonna go and stop the Cron microservice processor, which is the external processor that will run, and we got a 200 OK on the stop job. Over here we have the stop job, and then if we clear this guy, let's just clear this. Well, that's fine, but let's clear it, and then we'll give it 30 seconds, and then you will see it will only log 1 job, which is the internal processor, and then after that we'll just do the start of the jobs to show that this start trigger will then execute. Will basically start the job and have the two jobs continuing as per usual, and then the pause and the resume work fine, which you already proven. As you can see, only 1 job was executed, internal, and execute internal business logic. This is what we're printing out on the job, and only 1 is executing. That's good. Now we're gonna start this job. Let's go back to the start, and let's start the Cron microservice processor, which is the external processor, and it basically told us that the logic is here, and external is there, and internal is there. So both jobs are now running as per usual, because we have both of them printing the logs that we want to be printed out. And this is internal, which is that, and then this is external, which is that, and this is what we see on the logs output over here. And we can basically allow the job to automatically run, automatically execute without us awaiting anything. So we can log any exceptions that are thrown whilst the job is running, and we can go to see the failures. That's a different conversation, different story. So failure mechanisms, retry mechanisms, all of those can be put in place to make sure that your automated runs can run as effectively and efficiently as they can. But for now, this is how you can set them up dynamically. Make sure that whatever processor that you are running is actually a processor that is available to actually run that particular class, and you have a Quartz processor that is an abstract and it implements the job interface, which is what is required for you to create your job details this side. So we want to keep this short and sweet, and I think this will come in very handy for automated processes and automated runs. So please do pull the code, work on it, play around with it, see how it can work for you to make sure that you have ease of implementation within your microservices architecture. And I think that's it for us. Until next time, for now, cheers.